Hi everyone, welcome back to my math teaching channel online today. Um, in this video, I would like to show you the sequence of our course, Introduction to Calculus. So we have learned so far, we have learned on about the derivatives and we have learned what is the limit, what is a calculus, what is the rate of change and slope of tangent line. So before I get into the chapter 4, application of derivatives, I would like to show you, yesterday we learned about implicit and explicit function. So today it's just one more mini lesson, the small section of another part, which we call a higher derivative. And I mentioned about this before to you, which is the way we do take derivative the same like we do the first derivative. But I just want to go through it quickly with you so you get the idea about what is higher derivative mean before we move on to solve the word problem application of derivative. So on the board, I have a function, right? And I call today lesson is higher derivative. So this is the function, and this is just one function. This is not the opposite composition function, right? Not the function in another function. So this we're talking about higher derivative. We're not talking about the chain rule, right? So let's say this is y function. You have x to the power 4 add 2x to the power 3 minus 5x squared plus 3x minus 6. So we take the first derivative, and the first derivative we call the y prime, right? And if you use another notation, I believe that dy over dx, right? And then for the second derivative, I think the notation like dy with the square like that, but it's not really square, right? It's second derivative dx. And then the third derivative will be d to the power 3 over dx, something like that. But let's forget about on this notation for now. It's just a different way of the teacher use in different textbook, right? Let's just use a very simple one in here. So y prime, which is the first derivative, we take derivative 4x to the power 3, right? That's how we do. Adding with 3 times 2 is 6x to the power 2 minus 10x plus 3 and minus 0, right? This is the first derivative. Now let's take the second derivative. And the second derivative, I put a notation here is y prime equal, again, we're going to do exactly the same. So 12x to the power square adding with 12x. So that is the second derivative minus 10. So the third derivative with the 3 primes here, right? This second with 2 primes, this is the third derivative, 3 primes, will be 24x plus 12. So that's the third derivative. Now let's take the last one. The fourth derivative, 4 prime, will be equal to 24. So that's this on about the higher derivative. So for each of the derivative, we just do the same, but we just take derivative again, right? So first derivative, we got this function. Second derivative, we got this. And then we do derivative again, we got third derivative until fourth derivative. And of course, the fifth derivative, this is 0, right? Because any derivative of constant will be 0. So that's all about the higher derivative. I just want to show you, just give you the concept that in the future, you might have to do the second derivative or third derivative. Now, there will be more complicated function with the square root, blah, 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 for you to practice the higher derivative. But I don't want to go too deep into that because it's the same feature, it's the same way you take derivative of any square root or any function. And I show you that in previous lesson already. So now the next video, I would like to move on with the application of the derivatives, which is chapter 4. So stay tuned and see you in the next minute. Bye for now.